Hello, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending Benefits of Virtualizing the Diameter Signaling Controller for Your LTE Networks, presented by Sonus. Our presenter today is Bill Welch, Senior Product Manager Signaling at Sonus. Just a reminder to everyone in the audience that within 24 hours of this webinar, we will provide you with a link to the on-demand version of today's webinar. During the webinar, we encourage everyone to submit their questions via the control panel, which will then be answered at the end of the presentation. At this time, I'd like to turn the presentation over to Bill.
Thank you. So today I would like to cover basically the benefits of virtualizing your LTE network. And so let me introduce myself. So I'm Bill Welch, a Senior Product Manager over at Sonus for signaling. That includes both SS7 and diameter signaling. So let's jump into a quick agenda. So let's first kind of just provide a brief background on the functions and use cases for diameter signaling controllers in LTE networks. And then we will jump into the benefits of virtualizing those diameter signaling controllers. And then finally follow up with how those virtualized DSCs and SDN combine into delivering significant cost savings. So before we get too far, I just want to introduce where the diameter signaling came from at Sonus. So there was a company called Performance Technologies, which we acquired earlier this year. And with that acquisition, they are now fully part of Sonus. And so from Performance Technologies, we've gotten essentially a SS7 STP and also a diameter controller. And so let's first talk about what service providers want. On the left-hand side here of the chart, we have sort of the traditional hockey stick. Call this the diameter, signaling storm, of showing the the growth rate of basically diameter controllers, diameter signaling controllers. And as you see here, it's very much exponential and kind of going up and to the right, both from a revenue standpoint and the number of transactions per second that are licensed out. On the right-hand side is also an Infonetics survey that was done, and it was basically a survey done to talk about NFV of essentially which parts of the network or which applications operators are looking to convert over to an NFV architecture. And so in blue here, covered in the red, we're highlighting the mobile core or virtual EPC, which essentially that is where the diameter lives. The diameter is essentially at the hub of the core. And so here we show, in 2014, 2015, 14% of respondents are looking to get over to an NFV architecture, and as you show here, kind of weighed against other type NFV deployments. And so, as we all know, diameter solutions are in a mobile network are essential for services, and going forward, SDN and NFV are going to be key technologies to increase service velocity and lower costs, and that's really what we're going to try to cover here, some of the ins and outs of that. So moving on and talking a little bit more about NFV, what are providers in SDN? So on the left-hand side here, here's what operators are looking for. You see basically scaled services up or down quickly, so obviously the elasticity coming into from an NFV deployment driver, and obviously using software for quick time to revenue. So it's all about basically getting there faster with software versus using a hardware only and or hardware software solution. On the SDN side, on the SDN NFV application side, these are the things that basically operators expect SDN and NFV applications to do to produce new revenue. So they're looking for use cases such as bandwidth on demand, dynamic policy control with pricing, and essentially elastic service chaining. And those are really the most important things that operators are looking for. So here again, both of these surveys are actually coming from the same Infonetics report, and it's all about time to market with new services. And so operators are looking for a quicker time to revenue with their existing services, and being able to make those elastic as basically demand kind of scales up and scales down, but also to go after new markets and new services with their offerings. So let's dive into kind of the plethora of use cases for a diameter controller in an LTE network. So before we get too far, let's just quickly talk about what diameter is. Sort of jokingly, diameter is twice a radius, and that's really where it comes from a pure standpoint. But diameter is the IETF defined protocol designed for authentication, authorization, and accounting, and was really a whole host change and improvement over the radius protocol. And so this improved failure handling, it's a more reliable message delivery, bigger information elements than radius, improved security, extensibility, and more flexibility in discovering nodes and node capabilities. And 3GPP also has two signaling protocols: SIP, and that's basically to set up the voice and multimedia IMS sessions, and diameter, essentially used within the enhanced packet core, and essentially used for both evolved packet core and IMS transactions. So moving on to the next slide. Now I'll just bring up this animation to kind of complete the picture. So what does the diameter router do? And so on the left here, we have sort of the n squared problem. As you're adding particular network elements into your network for mobility, it could be for charging, it could be your backend databases, and you're scaling up your network to support your LTE deployments, you're adding additional nodes, and those additional nodes have to have kind of a mesh interconnector model from a diameter standpoint in order to effectively make the entire network work. And so what a diameter signaling node is doing is essentially taking all that traffic, doing aggregation first, centralizing the routing so you have a single spot in your network that you can interrogate and use to control this traffic. And essentially do load balancing within the network to make sure everything functions properly, but in particular when things start to fail. So you have an MME kind of acting up and causing problems, you wouldn't want that MME to start propagating those problems over to other network elements and then actually start bringing down parts of your network. Those are the types of things that a diameter router is eventually set up to do to control the network and make sure that all that information is flowing properly. And so the left-hand side is really the core of what core routing is for a diameter router, basically in bringing control to that overall diameter traffic. And then you have basically an edge deployment, diameter edge agent, and that's really for security routing and protocol interworking at the edge. And this is where you have your home network, your visited network, and your interconnect with potentially either direct or through an IP exchange carrier, and that's basically allowing the IP exchange carrier and your home network and your visited network to all kind of talk to each other in a controlled manner and provide that security, routing, protocol interworking, and in particular kind of a single face to hide things of your actual network deployment. So for example, you're at another HSS in your home network, you don't have to go and notify your interconnect provider. You don't have to go and notify the access provider that is the visited network. You can hide that topology and hide that the actual end deployment from them and just provide them a single entry point. Another important aspect is your interworking function. This is where you have LTE subscribers, 4G LTE subscribers roaming onto a 2G or 3G network, and with that you need that scenario in cases where you don't have ubiquity for LTE deployments. And so North America has a whole lot of that with the carriers that are here, but there are many other parts of the world that don't have that LTE footprint that it either matches or surpasses the 2G and 3G rollout. And so with this, you're basically taking an LTE 4G handset, authenticating it on the 2G network, and allowing them access to that network to support their services, and sort of a roaming scenario. And the last one is all about interoperability. You may have protocol variants and interoperability issues between different diameter nodes. This could be due to just general, vendor differences when implementing standards, or it could be things such as differences in overall, 3GPP releases that are supported. There's always some backwards compatibility capabilities there, and usually a layering capability. But again, you want to make sure that everything works, and you don't have to, upgrade the entire network concurrently, and not have any control with that. So those are just diameter node does, and we're going to dive into more detail of what's going on. So talking about different diameter solutions, in use cases that are defined, so you have different sources. You have the DRA coming from 3GPP. You have the diameter edge agent coming from GSMA. You have subscriber location functions, translation functions, router, and load balancer. Those are all examples of where this stuff is all sourced from. And moving on, we also have the IETF to kind of deal with from an alphabet soup perspective. They have defined basically relay agents, proxy agents, redirect agents, and translation agents. Those are, we feel that all those capabilities are critical of a diameter solution, and those are all parts and capabilities that you should consider when rolling out a diameter routing solution. And so let's go into sort of some of the main components here and use cases. So we have basically the diameter routing agent coming from 3GPP, and so this basically allows multiple PCRFs to be deployed, and that includes basically the policy and charging functions, and it's basically routing messages in a stateful way over to the appropriate PCRF, and and adhering to the 3GPP defined spec is an important aspect of that. I kind of define this particular problem and solution as kind of the Where is Waldo problem. So you have a subscriber in your network, he is attached to your network, he is essentially terminated both on a P gateway and a PCRF, and you need to know, as service changes are being implemented, and the user is kind of routed around the network, you need to know where they are and what associated sessions are with them. And this is essentially, getting the appropriate diameter messages over to the PCRF in OCS in a way that allows it to be in a stateful way. And so you're solving that kind of Where's Waldo problem, and being able to scale up that, in large operator networks, in the tens of millions. And then you have the diameter edge agent, again coming from the GSMA, and again it's a single point of contact in and out of the operator's network. The key aspect there is topology hiding, where you're really hiding the end IP addresses and deployment of all your equipment within the visited network or within your home network. And an important aspect there is it's all about security. So you wouldn't want essentially a problem, permeating in a visited network, one visited network to permeate back over to the home network, or potentially back and boomerang back down to another visited network. And so you wouldn't want one problem to kind of permeate around into different operators and really cause a much larger problem. And so the powerful kind of security, screening, and routing capabilities are key aspects there in that type of edge deployment. So a little bit more detail. Here's some call flows for a DRA. And so you have your diameter CRC message coming in, and you're essentially getting it over to the appropriate PCRF, and then keeping that session, that IPCAN session, for that particular subscriber, up and running and associated there in a stateful manner. Again, this is I kind of call it solving the Where's Waldo problem, or where is the subscriber session found. A key aspect of that solution is scaling up to and depending on the implementation of that, it's really enabling geo-redundancy within the diameter router, and or basically PCRF in OCS. So that's some things you always should be concerned with. Moving on to slide 12, again, back to the diameter agent. So this is a GSMA recommendation again, single point of contact in and out of the operator's network. Topology hiding is the key. I can't stress that enough. and the policy, powerful screening and routing functions also enable that. And so handling congestion and flow control on the transmit and receive side, and manage really peer interconnect is the key there. So either as a home provider, a visitor provider, or potentially an IP exchange carrier, those are all particular deployments that are required, or will need a diameter edge agent. So I haven't spoken very much about the subscriber location function. So in many networks, either due to having legacy kind of HSSs, or potentially a particular scaling problem with an HSS, or just having an excessively large network, tens of millions and maybe even 100 million subscribers, there may be a need to break up your HSS configurations and segment them. So it could be broken up by region, of the country or the deployment. It could be broken up by something as simple as particular domains, or it could be something as simple as kind of an odd-even number breakdown. In this case, you need a capability to make sure that those diameter meshes that need to hit a particular HSS are routed appropriately. And so you need to, first segment and break up your HSSs in a way that makes sense in some sort of higher level logic, and then instrument the diameter router to basically follow that logic and make sure you get over to the appropriate HSSs. And again, the motivating reason here is you want a more redundant and resilient kind of scenario with your HSSs in your subscriber repository. You don't want a single sort of HSS instance to basically completely torpedo your entire network. And so you're doing it from kind of a paranoia perspective of making sure that you have as much resiliency as possible, and making sure that if single elements go down, you're not really bringing down your entire network. And so this is really a basic feature inherent with DSCs, and it really provides you greater flexibility and service capacity management. And it's really routing parameters defined by the operator. So depending on exactly how you go about logically breaking that up, you need to have essentially this basic lookup function where you have a database and or simple rules, either a database of all your subscribers with telling it which HSS it's at, and then having the full-blown subscriber subscription back within the HSS, or you have very simplistic rules that then basically direct you to the HSS. Either models work, and both are need to be supported, in particular for really large networks. So let's talk about the translation function interworking. These are both two different things. We did talk about interworking between map and diameter interfaces, and so this is defined within 3GPP TS 2985, and this is again where you have 4G subscribers coming and roaming onto a 2G network. And the other aspect you have is protocol normalization interoperability. So again, you might have some nodes in there that either have some bugs, some problems, just basically instantiating and developing their diameter interfaces in a slightly different manner, different assumptions based off of the same spec. And you need a way to control that within your network to make sure that one bug or one problem within one node doesn't completely hamper your service efforts, and you have a way to kind of mitigate that and continue operating your network. So let's talk about the translation function here. It's basically a function between map and diameter, and so you have essentially a 2G, 3G map-based message coming in, and you're translating that over to a diameter-based interface. And I think I actually have a slide coming up here. Actually, I'm sorry, I don't have a slide. I thought I had a slide there. And here's basically all the interfaces that are involved in that. And this is important, obviously, when you are you don't have LTE ubiquity, where your LTE deployment isn't a complete overlay of your 2G, 3G network, and you're in the process of building, or you just don't have the economics to deploy LTE everywhere, and you still want to rely on from a roaming standpoint, either built as your own or from a partner. And so here's basically some more details on the standardization of the roaming scenario. And I'm sorry, and here's the slide I was looking for earlier. And so again, you're starting with converting basically an SS7 map authentication message over to diameter authentication with the HSS. And so you need that interworking function in between the SDP and the HSS to make that translation. Okay, so we've kind of gone through the use cases that are out there for diameter, and I'll start focusing on some other key aspects of a diameter solution. And so here's a quick summary table. Due to the interworking, you need SS7 integration. We talked about the advanced routing and screening, both from a core perspective, but also from an edge perspective. Congestion and flow control are important, both from a core and edge perspective. You need virtualization and being able to support multiple instances. You need that message modification capability, certainly from a vendor-to-vendor interop perspective. We did talk about the IP-CAN session routing and capability. That's again solving that where is Waldo problem, and you always want extensibility and security to be part of this. In particular at the edge of the network, security is a key aspect of this overall solution. So let's talk quickly about flow control and congestion, and we'll start moving on to the NFV and SDN aspects here. And so flow control and throttling is really performed on a number of messages, and you need to allow basically both receive and transmit for those external agents. And congestion management is really important, especially when you have an element kind of misbehaving, causing a whole bunch of problems and really flooding the network with messages because it's kind of out of control. This was a key problem early on with early LTE deployments. This both flow control and congestion. There were network operators that deployed an LTE network and didn't necessarily have a diameter solution in place, a diameter routing solution in place, and they were exposed to these problems and bugs and had some catastrophic problems. So those are back a few years ago, but certainly something to keep in mind. And so the advanced routing tables, you want to be able to make sure you can identify, incoming messages, take a look at all the headers, particular filter on particular AVPs, and either send it out to the destination, figure out if it's relay or direct, and do load sharing, load sharing possibility of kind of round robin or other ways. And this is really you may have multiple routing tables to deal with different business either partners and or business needs. And so another thing about one thing about extensibility, haven't talked about this as of yet. So we talked about the session manager capability from the DRA and the translation function. But other things here is basically kind of a roam steering application. So we have, in our particular solution, we have kind of extensibility through a diameter-like API socket, and that's you just don't want to kind of hamstring your way with just having a single vendor kind of controlling everything and delivering everything. You want to make sure that that vendor has the ability to kind of layer in applications. In our case, we have a roam steering application coming from a partner of ours, and that enables operators to help the end user select which access provider they would use when they are roaming to a particular country. So there may be a whole list of local operators that are there and available, and then what you're doing is you're assisting the end user in an automated way to roam to a particular preferred partner over others, versus just kind of doing it randomly. So let's move on to the more important part of the conversation. Up to now, it's really just kind of a backdrop of diameter, and let's talk a little bit more about virtualization. So what's basically a virtualized router? So here what we're talking about is essentially it's a diameter router running on a hypervisor. This could be something such as VMware, KVM, Hyper-V. There's a whole cast of characters out there that provide hypervisors, and you're essentially layering that on top of the COTS hardware. And so what the hypervisor is essentially allowing you to do is hide and obscure and pull apart basically the storage, the network, the memory, and CPU. So you don't have to, in the previous world, if you were running on COTS hardware, it would be you had to run on COTS hardware, X, and the solution provider will provide you a laundry list of things like you need to run this particular server hardware, you need to have this type of memory, you have to have this type of controller, you have to have this specific NIC card, this hard drive, this RAID system, on and on and on. And that would be the exact configuration that they would kind of certify and run on top of, and only allow you to run on top of, even if you were running on COTS hardware. What the hypervisor is really doing is abstracting that out. So it provides kind of a middle layer here where when you're running an application in a virtualized environment, you have requirements of the application of the hypervisor container. You no longer kind of have requirements on the actual hardware. Now, that not saying they're completely disconnected, but it provides a level of abstraction. So, for instance, in a deployment, I might require 4 virtual NICs, a particular, 4 cores, this many CPU cores, this much memory, and this much disk space. But with kind of a hypervisor technology, you can choose to kind of deploy that on top of many different pieces of equipment. So it could happen to be HP, it could happen to IBM, it could happen to be whoever. And as long as you meet those minimum requirements and are able to map those hypervisor container requirements of the application onto that hardware, then you're good to go. Well, with that comes, obviously some caveats. There is some, normal kind of hypervisor overhead, somewhere in the, small percentage range. But the advantage is again, that abstraction. And the other part too is you're really able to reach very low scale to very hard scale with flexible deployment. So I could take, an instance of a diameter router and put it on a very, robust hardware platform or very capable hardware platform that may have, 12 CPU cores or 16 CPU cores or 20 CPU cores, and either put multiple instances down of that with different VM containers, or basically scale it up and scale it down, where I can take a single instance and just add more cores and add more memory and add more disk space, and just scale it up, single container, single instance on top of a hypervisor, and just scale up the resources that are within there. And so this provides some flexibility for the operator, both from how you would go about deploying it within the hypervisor, but certainly giving you the capability of kind of choosing your own platform from a hardware perspective. And so I'm just showing here, how you might go about taking different server instances. That's what the gray block is kind of, larger gray block is kind of substantiating. And you could just add, the DSC on top of a server, and you could also be hosting other applications on top of that, depending on kind of resource availability of the overall system. And you can just kind of chain on and on from there to kind of get from low scale up to high scale. And so let's take some time and discuss this enterprise pod use case a little bit. And I kind of put this DevOps label on top of it. So some of the carriers that I was speaking to, they're exploring this idea of kind of a DevOps approach, and that's essentially the folks that are developing and architecting the solutions are actually operating it also. And that's quite different in larger operators from what's happening now. You have this whole handoff process. You have kind of an architecture group that kind of puts it together. You have kind of a deployment group that's then actually deploying it. And then you have kind of an operations group that's kind of managing it day to day. In this sort of environment, the key here is you're trying to reach enterprises with specific service offerings that they and glob on to. And in that environment, you want the ability to kind of substantiate changes very quickly and minimize the impact to other parts of your network. So this concept of kind of an enterprise pod has kind of come up, where you take a diameter router, a P gateway, and a PCRF, and maybe even charging, and essentially set up a pod specifically for corporation A. And that way, if I want to do some really new services, new capabilities that are only specific to corporation A, I can quickly quickly basically put those into Corporation A and not impact any of my other corporations that I'm servicing out of the network, but also, probably the larger portion of kind of residential subscribers or subscribers that, don't necessarily have kind of a corporate flag, flying above them. Um, and so you could substantiate, in a virtualized environment, you spin them up, spin them down from a resource standpoint. Corporation A has a 2-year contract with them. At the end of that, you spin it down. They don't have those services anymore, and you could then reuse that hardware and essentially capabilities within another corporation. And again, doing this sort of pod architecture is really all about having a particular or session coming out of the access network and terminating within this particular pod. And what you're really trying to do here is the customer, the end customer, who is essentially an employee of Corporation A, would have one IPCAN session that would be best effort internet, and then this secondary IPCAN session that would be designed and set up for access to sales information, corporate information. It could be real-time communication directly related to that corporation. That you have that sort of separation at the phone standpoint, where essentially the first IP session is going off the traditional PDN gateway and PCRF, and you're keeping those kind of service changes and new services and service changes away from the main part of your network and really focusing in these pods. And that's really the thing here. And so you really have you couple that with essentially kind of a DevOps environment. So if you have the folks that are actually developing the actual solutions for these corporations, they're going to become very intimate with the companies and maybe make recommendations on new services that could be applicable to Corporation A versus Corporation B, and those are the guys that are actually operating it, so they kind of know the ins and outs of the services and able to kind of help stand it up. And you obviously have teams of folks that are really set up. The reason this is ideal and something operators should explore is this really steers away from the issues. This is you're offering services to a corporation, and it's basically for their benefit and you're steering away from kind of the over-the-top players and that whole net neutrality issue. And you could really these are the customers, the corporations that are kind of willing to pay for these types of kind of guaranteeing services, where you either run into customers unwilling to pay and where there isn't net neutrality issues, or actual kind of legal framework and issues with net neutrality. So again, this is a use case that's really facilitated by both NFV from a spinning up a virtualized environment, but also talking about the SDN domain here, the green box. You essentially have the SDN controller will have to facilitate that essentially corporate specific evolve packet core instance to the EPC core, and any sort of caching or modifications that go on there, and then interconnect with corporate A. If they're having something like a bandwidth on demand event where they're going to do a big corporate launch, and basically they're going to have all their employees and basically kind of do an around the world sort of thing, and you want that to be guaranteed for them, well, you're going to have to kind of scale up and scale down kind of bandwidth, both from that instance into the core and corporate A. And so that's where sort of the NFV and the SDN kind of come together to kind of create this capability for the operators. Moving on. And so one other thing I just wanted to highlight, one of the things we're looking at is basically integration of SIP and diameter at the edge. This is a type of virtualization. We're essentially virtualizing applications on top of our SPC platform. For us, it really makes sense because of similar functionality and co-location, and that's really what drove the consideration. And so here you have basically, kind of in tandem, a diameter edge agent, an SPC at the edge of the network, securing basically both SIP and diameter. And outside of that realm, further in the core, you have the traditional diameter router in the core. And then if you go here, we're talking about providing an integrated option here of basically taking our diameter application, porting it on top of a virtualized environment, which so happens to be on top of our SBC. All kind of and the value add here is there may be common security policies that are required for both the SBC and diameter side, and then those common policies could be essentially instantiated once rather than being duplicative in two separate virtualized installs. So it's just kind of a way to think about adding more efficiency and footprint at the edge. And so let's talk about more about DSCs and SDN, how they combine significant cost savings going forward. So one of the things that you have to think about, is the economics. So here we have kind of a resource consumption, and time kind of perspective. Resources are going up over time. You hope you're having, more consumption either from a bandwidth perspective, subscriber perspective, or the services uptick, and then that is turning around where you actually have to add more resources and capabilities into your network. In the traditional model, you have sort of a 2-year, 1-year sort of perspective where you're adding it well ahead of the consumption, and so that's kind of the green. You're adding in big steps. You're adding. I need to expend some capital, do some things here, and add it in order to meet that capacity and resource demand. And you go from that sort of model where you're adding it well ahead. It could be 18 months, 2 years out, to a little bit more on demand or just in time. So the increments are smaller, but you're being much more kind of efficient in kind of resource allocation. And so NFV and SDN really kind of give you that capability to quickly add, and it could be several minutes, it could be several hours, it could be over a day where you're adding those resources on demand and bringing them up in order to kind of meet that growth curve. And so the reason I chose the colors was in order to stay in the black and not go into the red as an operator, focusing on the black here, you have the capability. And from a CFO perspective, look at all that green you're saving in the steps. So you're really basically not expending that capital and being able to use it. Able to use that elsewhere in your network. It could be for marketing, it could be additional service offerings, it could be whatever, but you're really, you're saving that green and staying in the black is sort of the message. So just a quick summary. Quick summary on this of what we're talking about. So the DevOps model with scalable and flexible services. Customers are looking for scalable and flexible services for new service offerings. You break the traditional telecom economics of kind of build it and then they will come sort of models, and you're really leveraging the economics of what SDN and NFV kind of bring. And from virtualization perspective, you're not boxed in. It's a sort of a use your own methodology. Either use, in the case of where you're using something and then retiring it, back to the enterprise case with the pods. You may have an enterprise that goes away. Well, you don't basically take that hardware and run it over in the parking lot. You can reuse it with another corporation. So use and reuse your own hardware from a common pool, and you don't have separation of pools from a hardware perspective. And that's really the net of what SDN and NFV kind of bring to operators. So that is it.
Thanks, Bill, for a great presentation. We've had a few questions come in during your presentation, and I encourage everyone to submit their questions. The first one, many people say that software is not as secure or as robust as hardware. Can you comment on that from a diameter perspective?
Sure. So that's a key aspect. If you're being less secure, you're not really offering a solution. The security profile going up and to the right. So as new things are being found and new exploits are happening, and there's layers of additional security certifications that are kind of going on. It has to actually be more secure. And you actually, if you think about it too, the Linux has really started to, or has already, kind of won the battle of the operating systems from an embedded standpoint. So it used to be that there was a whole host of um, embedded operating systems that had to be secured. They would be used with basically vendor A and vendor B and vendor C. But if you think from an economies of scale standpoint, wouldn't I want my essentially networking equipment to be secured with say something like Red Hat or some other Linux derivative that is used on thousands and thousands of different deployment models out there. It could be a web server, it could be a database, it could be basically a web UI, it could be basically an embedded signaling product like this. And so that economies of scale of essentially getting actually really helps us to button things up a whole lot more. So I guess I fundamentally kind of disagree there, where you have this commonality coming from everybody kind of moving to Linux, actually getting things more secure and sort of faster time to repair. Is actually a whole lot more capable. Like if you have everybody beating on somebody like Red Hat or somebody else, um, let's talk about something like Bash. There was that Bash security issue. Well, they very quickly responded, and then all the folks basically got it out there to their customers. If that was somebody like a small scale player that had an embedded basically OS, they might be less likely to respond. So I actually think we're moving to a more secure environment with software rather than a hardware approach.
That's definitely a great outlook. Another question we had come in is, which hypervisors does your solution require?
So today we're seeing most demand for KVM, so that's what we're looking. We're supporting in the first round, and we're evaluating other hypervisors such as VMware. It's a very big part of the market, and for us it's not that much of an incremental change or add to support additional hypervisors. The key kind of little asterisk there, kind of answering that question is it's a balance of how much we invest and tune things to a particular hypervisor. So if we want to be kind of completely agnostic to hypervisors, we have to kind of stand back and not get too much embedded with a particular kind of tuning parameter or capability of hypervisor A. And it's a balance of the number of how much hypervisor versus the number of hypervisors we support. And so it's just something to think about and consider, because that tuning and kind of reach into the hypervisor may give you additional performance, but it comes at a cost of having to kind of duplicate that work across the hypervisors.
And a follow-up question that came in right after that is, in terms of HWCOTS, what features are required for the solution?
Sure, sure. So right now, our particular solution, we don't require any underlying, like I see the question here. We don't require a particular developer's kit from Intel or others. There are other applications that require that because of some of their media handling capabilities, and you really need that acceleration to kind of get anywhere close to kind of a hardware-based kind of accelerated solution. But as now we're not linked to that particular Intel library. We may, again, it's the same question as the hypervisor. How much optimizations do you do either on a particular piece of hardware with a library or a particular hypervisor? It's a trade-off. The more you tune things and go after it, it's a problem. So to go back to kind of the spirit of the question, so you need a minimum of 2 VM containers. Each one of those VM containers needs to have 4 CPU cores at 2 gigahertz or higher. I think we're talking about 65 megabytes of disk space and the ability to instantiate 8 virtual NICs. Those are the kind of general hardware, and I think it is The last item is the number of gigabits of RAM. I think it's 3 gig of RAM, if my memory serving me right around there as far as in each one of those hypervisor containers.
Okay. The next question we had come in is, can your diameter router function be orchestrated?
As of right now, no. That's something we're definitely planning on adding. So we're doing it in steps. We're first essentially taking our application, um, out of an appliance, out of an x86 appliance, um, and instantiating on top of a virtualized environment. And we're definitely planning for that in the future.
Nice.
That is this is the first step, and certainly that the orchestration part is a key aspect of getting to a full NFV architecture.
Yeah, absolutely. That's pretty exciting. We had another question come in. So, what do you see as one of the leading use cases for virtualizing diameter?
So the leading one, which I think resonates a whole lot, is actually that enterprise enterprise kind of hub scenario, um, because it really operators are looking for ways to go after new capabilities and new markets, and essentially go after markets that are ripe with money to spend. So if you're looking at real-time communications as a particular solution that you want to provide to your end customers over an LTE network for a corporation. I think that's really kind of the sweet spot of where I would think operators would be best to spend their time and money. Because you're steering around, you're not impacting your existing network. You can continue to run your traditional subscription-based kind of more towards end user type service profiles and pricing and stuff, and you're heading into a market which they overall as compared to an individual. So I think for me that's the primary use case and motivation is to focus on business services overall, kind of end user services.
Cool. So we have just a couple more questions. The next one, can one have both hardware and software diameter solutions in their network?
Most certainly. We could potentially see, you know, uh, normally operators are basically putting a core element or core set of elements for the core part of the network, and just from either a phasing standpoint or a cost standpoint, or just a security standpoint, they are then doing a separate edge deployment. Um, and so having those both concurrent within the network is fine. We're not we haven't seen too many requirements where customers are looking to kind of mix and match kind of a hardware-based solution and a sort of a virtualized solution together. But I don't see there's anything fundamentally wrong with that either.
Right. We have about one more question, and this is, I think, a good one to end on. So, what role does diameter play in a VoLTE network, and where do you see that going in the next few years?
Sure. So diameter it definitely has a role to play, within a VoLTE network. So generally, operators are setting up separate, IP CAN sessions to support that VoLTE network that is separate from their, best effort internet, session. And so by rolling out VoLTE, you're adding more sessions to your P gateway, you're adding more sessions to your PCRF, and you're essentially adding more diameter traffic to facilitate that. Um, and so that's just a natural fact. And folks like Oracle put out their diameter index, and they call out separately the traffic attributed to VoLTE. And so they've separated that out from mobility. They've separated out from sort of service in kind of quota type PCRF type scenarios, and roaming. And so something to take a look at. But it's certainly VoLTE will add to the diameter signaling of the network, and it all depends on how quickly an operator rolls it out, the availability of handsets to support it, and how quickly customers actually go ahead about exploiting those capabilities.
Great. That's about all the time we have today. I want to thank everyone for attending. Benefits of virtualizing the diameter signaling controller for LTE, presented by Sonus. Again, our presenter today was Bill Welch, Senior Product Manager Signaling at Sonus. Thank you, Bill.
Yep, thank you.